In the first design challenge, students are faced with what shape should be used for rotating the satellites in order to produce a minimum current for the satellite to function. So in this case, you're going to need some items that may help. I have some solar cells that I got. You can get these from most science supply companies. Pitsco offers a project box for a solar racer. And even though I don't really want the racer, it gives me the solar cells and all the other materials that I might need in order to complete the project. You're also going to need an ammeter. I have a digital one here that I'm going to use to measure the voltage output from the solar cell. Now, as part of the science of this, I have students conduct an experiment before they actually go through and do the design part. And so I have a solar lamp that I have here, but any light will really work, and my solar cell. And what I'm going to do is I'm going to turn on the light and I'm going to measure the voltage, and I ask students what things might affect the voltage that this solar cell will produce. By leaving it as an open-ended question, the students can investigate what it is that they may be interested in. So some students may talk about the distance this is away from the light source, the angle at which it's going to turn, the shape of having multiples, like if I have a second or a third, and how they connect through. So there are all types of open-ended questions that students can investigate. And in a classroom, it's great if you can have the different groups investigate different questions, because they can come up with some type of product or presentation that'll help inform the entire group before they go on to the actual investigation of determining the shape of the satellite. So let me give you a little information that might provide a help as you assign this design challenge to students. I have my solar cell and it's connected to this voltmeter. You could use an ammeter to measure the current, but in this case I just want to measure the voltage that this is producing. It'll be directly proportional to the current that'll be produced. And what you can see is, if I cover it, it should give us 0 or very close to 0. I have lights in the room, so it's getting a little bit of a reading there. And then I can take my light source, and what I can do is I can shine it on and just see, well, there's definitely an increase in the reading. I could do some things like checking the distance and see how that affects it. But what I'm going to do is I'm going to take this, and as you can slowly see, I'm going to rotate this and see what happens to the angle. And I could measure this angle, and I could do this at a distance, where I can then start to see, well, what's happening to the voltage as I rotate my solar cell. That scientific information is important as a first step for students in the design process. So now we want to determine what shape will work best for the satellite. So after students have done the science part, now we get to the engineering piece. And so for this, we have to determine what shape will work best. Now, I want to be able to rotate my satellite around, and so I have a little stool that students can stand on for circular motion type demonstrations, but a Lazy Susan will work the same, or anything like that. And although I don't have access to a 2D fabricator here, I do have access to cardboard. And so what I can do is I can take my solar panels and I can tape them on, and I can bend this cardboard into the shape that I might want. So I can bend it into a triangular shape, set it onto this turntable, and rotate it around in order to take my measurements. So I'd put my light really where the camera is, have it face here, and then take measurements, and I could slowly turn this around. That'll give students an opportunity to take the data that they need in order to be able to answer the design challenge. Remember, this is a design challenge, and so it's probably best to leave it open-ended. Simply present students with the question: what shape of the satellite should it take in order to be able to meet the design criteria we need, which in this case is the solar cells have to produce enough current to keep the satellite running. When we consider this type of option, being vague with students is a good way to see students become creative thinkers along the path of doing this scientific and engineering research.